In the boundless universe, where stars twinkle and galaxies swirl, there exists something so elusive, so mysterious, the neutrinos. Born from the heart of celestial bodies like the sun and supernovae, these subatomic particles are one of the most abundant yet least understood elements in the cosmos. Now you might ask, what exactly are neutrinos? Well, they are elementary particles, much like electrons or quarks, except they're neutral, meaning they carry no electric charge. But what sets neutrinos apart is their elusive nature. They're like cosmic ghosts, interacting so weakly with matter that they can pass through entire planets, even stars, without being deflected or absorbed. So, how many of these ghostly particles are we talking about? Brace yourself for this. Every second, around 65 billion neutrinos sail through every square centimeter of your body. That's right, 65 billion. You can't see them, you can't feel them, but they're there, journeying through the universe, through you and me and everything else. But here's the catch. Despite their abundance, neutrinos are incredibly difficult to detect. And why is that? It's because of their negligible mass. We're talking less than 1/1,000,000th the mass of an electron. Yes, you heard that right. A particle so small, its mass is almost non-existent. This makes studying neutrinos feel like trying to catch smoke with your bare hands. Now you might be wondering, why should we care about these mysterious particles? Well, because they could hold the key to some of the greatest mysteries of the universe. They could help us understand the inner workings of stars, the nature of dark matter, even the origins of the universe itself. So, now that we've established their existence and their mysterious nature, let's dive deeper into the world of neutrinos. Neutrinos exist in abundance, more than any known particle, but detecting them is a different ballgame. Imagine trying to find a needle in a haystack, but the needle is invisible, and the haystack is the size of our universe. That's the challenge scientists face when they attempt to detect neutrinos. These subatomic particles are constantly zipping through the universe, virtually undetected. They're produced by the billions in the sun and other celestial bodies, and they whiz through space at nearly the speed of light. Yet, because they rarely interact with matter, we hardly ever notice them. So, how do we detect these elusive particles? Enter massive detectors like the ice cube located in Antarctica. This gigantic detector is buried deep within the Antarctic ice, spanning a cubic kilometer. It's a marvel of scientific and engineering prowess, built at the staggering cost of $279 million. IceCube is designed to catch a glimpse of these ghostly particles by observing the tiny flashes of blue light produced when a neutrino interacts with an atom in the ice. This phenomenon, known as Cherenkov radiation, is our only window into the world of neutrinos. Yet, despite the size and sophistication of these detectors, successful detections are rare. On a typical day, IceCube might detect only a few dozen neutrinos. That's a few dozen out of the billions upon billions that are passing through the detector at any given moment. These numbers might seem disheartening. After all, we've spent hundreds of millions of dollars and countless hours of scientific research for just a handful of detections. But remember, each detection is a new piece of the puzzle, a new clue in our quest to understand the universe. Despite these daunting figures, scientists are relentless in their pursuit of neutrinos, and for good reason. Neutrinos hold the key to some of the biggest mysteries in physics and could revolutionize our understanding of the universe. And that's a prize worth chasing, no matter how elusive the chase may be. So, why this relentless pursuit of neutrinos, you might ask? Well, let's dive into the cosmic significance of these elusive particles. Neutrinos are integral to understanding the universe. They play a starring role in some of the most cataclysmic events in the cosmos. Think supernovas, the explosive deaths of stars. When a star goes supernova, it releases an enormous amount of energy. And guess what? Nearly 99% of this energy is carried off by neutrinos. That's right, these ghostly particles are responsible for carrying away the majority of a supernova's energy, traveling at nearly the speed of light, and escaping the dense stellar material that traps other particles. Now consider the number of neutrinos produced during the Big Bang. We're talking about a number so large it's almost unfathomable. A staggering 10 to the power of 89. That's a 1 followed by 89 zeros. And these relic neutrinos, or cosmic neutrinos, are still zipping around the universe, providing us a unique window into the birth of our cosmos. Neutrinos are also fundamental to the universe's balance. They help maintain the equilibrium between matter and antimatter, and their unique properties could hold the answers to why we live in a universe dominated by matter. Additionally, they serve as cosmic messengers, providing us with information that electromagnetic waves like light cannot. They can traverse vast cosmic distances, unimpeded by dust, gas, or galaxies, carrying information from the deepest corners of the universe right to our detectors. And let's not forget their role in nuclear fusion, the process that powers the sun and other stars. Neutrinos are the byproduct of these nuclear reactions, and studying them can help us understand stellar life cycles and the energy production of stars. In essence, neutrinos are the universe's most underappreciated messengers, carrying secrets from the heart of stars, the fiery birth of the universe, and the mysterious realm of the smallest particles. The study of neutrinos, therefore, is the study of the universe itself. The path to understanding neutrinos is filled with challenges, but the future looks promising. Diving into the world of neutrinos, one of the first challenges we face is their notoriously weak interaction with matter. These elusive particles are notorious for their ghost-like ability to pass through entire planets without a hitch. This characteristic makes them incredibly difficult to detect, let alone study. Every second, billions of neutrinos pass through just a single square inch of your body, yet most of them go unnoticed. Equally challenging is the sheer enormity of the neutrino universe. With an estimated 1 billion neutrinos for every atom in the cosmos, the numbers are staggering. Yet because of their elusive nature, we've only been able to detect a tiny fraction of these particles. It's like trying to study the ocean by examining a single drop of water. But fear not, for the future of neutrino research is bright and filled with potential. Enter the Deep Underground Neutrino Experiment, or DUNE for short. This exciting project, set to be one of the largest neutrino experiments in the world, aims to shed light on these elusive particles. With a price tag of $1.5 billion, it's a testament to the importance and potential of neutrino research. DUNE is expected to increase our neutrino detection rates tenfold. This massive influx of data will not only deepen our understanding of neutrinos, but also help answer fundamental questions about the universe. Questions like, why is there more matter than antimatter, or what are the properties of dark matter? On top of this, DUNE will also probe the mysterious phenomenon of neutrino oscillation, further enriching our understanding of these elusive particles. The experiment will generate a high-intensity beam of neutrinos and send it over 800 miles through the Earth to a massive detector in South Dakota. This will provide unprecedented data on how neutrinos change as they travel. The journey to unravel the mysteries of neutrinos continues, and each step brings us closer to understanding the universe. As we march towards the future, the challenges in neutrino research serve as stepping stones, not roadblocks. Each obstacle overcome brings us one step closer to unveiling the secrets of the cosmos. So we've traversed the universe, dived into the subatomic world, and stood at the edge of scientific frontiers, all in the pursuit of understanding neutrinos. We've learned that trillions of these ghostly particles pass through us every second, unimpeded by matter and almost undetectable. We've marveled at the monumental detectors, costing billions of dollars and spanning several kilometers, designed to capture the faintest signs of their existence. We've been astounded by the astronomical amounts of energy released by neutrinos during supernova explosions, dwarfing the output of entire galaxies. We've looked ahead to the future of neutrino research, a future filled with promise and potential, with new technologies and theories poised to unlock even more of their secrets. Neutrinos may be elusive and mysterious, but their study sheds light on the darkest corners of the universe. As we continue this pursuit, who knows what other secrets we might uncover.